Uh, Pretty fascinating information shared by Rahul there. But you mentioned black hole.
Yeah.
So let us come to our next section. Uh, so basically, first, initially, I have two questions for you regarding black hole. First, if you can very briefly explain to uh, a guy who doesn't know about black hole, what do they mean? How are they formed? Second, now this is a very personal question. We all know that black holes don't emit light, right? They don't reflect light. Now, even light can't pass them. So they're essentially dark, black. How do we detect a black hole then? What is, how do we do it? So
Uh,
yeah, these are my two questions to start the
yeah, that's a good
discussion.
question. I mean, once Einstein predicted the presence of black holes, people were like, how do they form and how do we detect them? So this kept us awake for a while.
Okay.
To answer the first question, how do they form? They form predominantly because you have stars which are very massive, and at the end of their life cycle, they have to die. And the way they die is they've used up all their stellar fuel, the
Okay.
fuel that they use to create fusion reactions, which
Okay.
powers the star. So it's the engine of a star. And when that
Mm-hmm.
engine loses its fuel, it's no longer able to produce this kind of energy that keeps it bright, and also that keeps it a sphere, and rather
Okay.
than implode because of its own gravity. So
Mm.
the moment you
Okay.
switch off that radiation pressure, as it's called, basically the kind of the pressure that you have because you have this light that is being generated, which is energy that's being generated. When you switch that off towards the end of its life cycle, gravity takes over. And when gravity takes over, the star starts to collapse.
Okay.
And spherical collapse. And what happens is as they get smaller and smaller, you're getting the matter density keeps increasing.
Mm.
And at a certain point, uh, you basically progress from being a star to being a black hole. You have multiple stages in that cycle. You perhaps make
Yeah.
a star depending on your masses, but you will create a black hole if it's a massive enough star. And that
Okay.
black hole is basically the way general theory of relativity looks at it, is it's a singularity in the space and time. What that means is, well, singularity in mathematics, for example, is a point where the singular point x is a point where the function basically explodes, or it goes to infinity, or it
Yeah.
goes to, remember. But the point is, though, it's basically a point where the function does not behave correctly.
Mm-hmm.
And the reason we call that a singularity in space-time is because the space-time is not behaving correctly, because at that point, at the very center of the black hole, what we call the singularity, the density of matter is infinite. According to
Yes.
the general theory of relativity, all the matter is comprised into a volume of 0 meter cube. And because of that, your density goes to infinity. A general rule of thumb in physics is that we don't like infinities in life. We
Hmm.
usually believe, good observations has told us that we've never detected an infinity, so it's a singularity. That's
Okay.
the whole story behind how a black hole is formed. You have a star that collapses. And your second question, which you must remind me again, what was it? It was,
How do we detect a black
oh,
hole?
yeah, good question. So how do you detect them? That's a good one. So we first detected them indirectly. You're absolutely right by saying that black holes don't emit light. By their very definition, they are black, which means they do not emit light.
Yeah.
They absorb light, but they don't emit them. In a way, it's a black body. So how do you detect such an object? Is you infer its presence. You can't perhaps directly visually detect them, but you can infer that they exist because of the way they affect the matter around them.
Hmm.
And
Okay.
that's because black holes are basically heavy objects,
Yes.
and
Yes. Yes.
heavy objects, exist. Like if you put it in a room full of some gas, all that
Hmm.
gas can start getting congregated inside that black hole.
Yeah.
And then what you can do is you can observe those gas particles go inside. So it's called a
Hmm.
accretion.
The way they
So
interact with their surrounding is proof of their existence.
exactly.
Gravitational waves and everything,
So
they
I
will produce it. Yeah.
think
However, so an important clarification to make is that what I described is an indirect way to detect black holes, where you
Okay.
look at how it affects the stars around it and things like that. So that you look at the fact that, oh, a star seems to be orbiting something, but it's nothing, and therefore you're like, oh, that must be a black hole. That's why we can't see it. That's an
Okay.
indirect detection.
Okay.
Direct detection is the gravitation, and that would
Gravitational waves.
so
so
you
Okay.
have to separate them both. Yeah.
So Rahul, to add on to that question, correct me if I'm wrong. I think Nobel Prize in Physics for 2020 was awarded for indirectly finding or detecting a black hole at the center of Milky Way. Is that correct?
Uh, from the center of the milk, I don't actually remember if it was for the Milky Way or something, but it was along those lines. You're right. Yeah.
Well,
In fact,
vaguely remember this. Yeah, sorry.
yeah. But I mean, for example, for the detection of the gravitational wave, we had a Nobel Prize in 2017,
17.
and
Yeah.
that was
Okay.
given to three major scientists who were there, who helped design this interferometer that we said that detects these gravitational waves. These are they call LIGO. It's called the Laser Interferometer Gravitational Wave Observatory. It's basically the device that helped us detect these gravitational waves, which prove the existence of black hole, and also was another feather in the hat for the general theory of relativity.
So, like you said, that one way to detect a black hole is by observing other stars or planets orbits around it, and we by orbit we can calculate maybe what is the gravitational attraction and what is the size, and if a very huge star is orbiting around something that is not visible to maybe light, when you call that means there has to be something that is the proof for black hole in a way. Is that correct?
Yeah, yeah.
And
That's
iteration rings.
exactly. So you have these accretion, like you said, they're accretion rings. So when something is
What
so
are
by
accretion rings?
I
I
should
don't
tell
know.
you.
Yeah.
Accretion is basically the word accretion itself means it's something where you're gradually, or I don't know, it's not a Merriam dictionary definition, but it's basically, taking in material, all right, the way I
Okay.
see.
Okay.
So, and when you have a black hole, it's again a very massive object, and it's going to have a large gravity. So, what that means is that matter would
It
start.
sucks matter, does
Yeah,
it?
it's subtle matter, and the thing
Okay.
is that matter does not just come in radially because they usually have some velocity. So they kind of
Mm-hmm.
do this kind of a fly, a kind of a spiral inside.
Okay. All
So you
right. All
have
right.
a lot of gas. All that gas basically ends up looking like a dosa, and that dosa at the center is the black hole, but the dosa itself, the rings of the dosa are basically what is called the accretion disk. It's a
Uh,
disk where things are being absorbed in.
okay.
And like I said, if you observe accretion around nothingness, or at least it looks like it's nothing because you don't see anything in the center, yeah, that's a very good very good smoking gun that, oh, there's a black hole there. There's mostly a black hole there.
Mm.
And a team of scientists did that. They did that very thing. So we look at we look at our own galaxy, and like you had mentioned earlier, we found that there should be a black hole at the center of it. And the reason being, we see all these stars, right? They seem to be circling,
Yeah. Okay. All right.
and we're not really sure what they are, what that was. But we never took a snapshot of the center. It's very hard to do that. So we were
Mm.
never able to see if it's a black nothingness or if there's something else there. Maybe it's a very big star. I don't know. But then we finally did that. We looked at a galaxy very far away. It's called M87. And that galaxy, we took a snapshot at the very center, and we did see a
Uh,
circle,
a circle. Okay.
everything surrounding a black circle. And from that, we were able to predict, is the mass consistent with what the accretion rate is and things like that.
Hmm.
And things were pretty consistent.
So, do
So,
we have a black hole in the center of Milky Way also?
yeah, we have a black hole in the center of almost every galaxy.
Galaxy. Okay.
Yeah,
All
yeah.
right.
So I vaguely remember this, that while as black hole are very very dense and a very compact objects, they are very 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 dense objects. So to actually see that there is nothing at the center and the accretion disk, we would need the size, a telescope at size which whose the size of the lens of the telescope itself is the size of the Earth, to actually get that resolution.
Yeah,
So
absolutely.
Oh.
yeah,
Yeah, yeah, that's the coolest thing. Actually, they did that.
but they actually did that by,
Yeah.
yeah.
So they had a
How?
bunch of telescopes. They didn't create one big telescope
Okay.
because
There are a bunch of telescope which.
exactly, but they had a bunch of telescopes all across the circumference of the Earth while it rotates, and they just kept on taking snapshots. And you kind of like they did this amazing amount of data
Wow.
processing, and so much of data. It was said that they actually had to fly all the data from one point to the other physically through the plane because that was faster than transmitting it through the internet. So they would
Internet.
actually
Yeah.
all these data,
Oh.
they would fly it around. And anyway, yeah, so they did this amazing amount of interferometer. They did this crazy amount of data processing, and they did that very thing. They made it an apparent lens. The lens was apparently was in effect the the size of the Earth, the diameter of the Earth. And yeah, you're
Wow.
right. That's the coolest thing. I was so surprised to hear that that actually worked.
Yeah. Wow. Black holes are definitely fascinating. And to anyone, uh, so it's not easy for a human brain to comprehend what a black hole is. Like if Earth has to turn to a black hole, it basically means to compact the all Earth into, let's say, a thumbnail, right? That is what,
Yeah, pretty
if a
small. Yeah,
normal brain has to understand what black hole really means.
absolutely, absolutely. Yeah.
Yeah. Wow.
And yeah, it's quite insane. It's insane to think about how dense that material should be.